Now we're going to look at device configuration. We have a device or some hardware piece that we want to tell how to behave, which is configuration of a device. So let's look at a project here that we already have. We already have a project, and there are device configuration. This an HMI panel has device configuration. What we're going to look is the PLC device configuration. So you select it here, and device configuration, let's say that's in properties here. So if it's selected info in the diagnosis or whatever, just select properties. So if I select the CPU, these are the properties for the entire CPU. And if you look, there are some components in the CPU itself. So these are network interfaces, these two. And here is a bus interface that's called Profibus. That's a legacy field bus. I'm not going to look at that. But if I select the CPU itself, I get these three, which correspond to what we just looked at. So now what you have to do here, you're not going to look at much in here. What we're going to do later is to insert some modules here. What you have to do is you have to set the interface addresses here on the Profinet interface to the network. This one is already being networked. So the addresses are in here, they match the addresses here, so you're not going to change. But if you just insert a CPU device view, you have to at least set the addresses. These are the addresses, they are assigned automatically. So if you want other addresses, you can enter them here. And if you want to use what we call a router or a default gateway, that's where if the CPU wants to communicate with some other device, but it doesn't know the address, and say, okay, whenever I want to send to that CPU, I'm going to send to the default router or gateway. And then that device has to find out where to send these data to get to the right destination. So that's what you have to set up. And here are some Profinet special information. In Profinet, you need a name for the device, and that's the device name down here that you can automatically generate, or you can change them, or you can set it on the device. Yes, you can change those. They are assigned. You can use a special program to assign these to. Okay, whatever. You have, that's the first one, that one. You have another one with exact same setup. You need to set the address. You see they are a little different here. See if we can switch between. So it's a 0. So it's a different, what we call a different subnet. So it's using another subnet here. And if you go to the network view, you can see the one network here and another network here. Back to the device view. Okay, with connections to, of course, we don't need those. Let's get back to device configuration. Yes, whatever. There are some other things down here. You could just go through. But this CPU can also be a web server. You can make web pages, so you can access information using a browser. That's a special procedure to do that. So if you want that, see general, you have to enable it somewhere here. Yes, and you say it's not enabled, so it wouldn't act as a web server. But if you enable it, you have to make web pages for it. What we're going to have a little look at here is security. This is the default full access. You can write to the CPU, can read from the CPU, and the CPU can have HMI access. We had an HMI over here. This is an HMI LOP local operator panel. can access this one, and you can change this to whatever. So if you don't want anyone to program the CPU and stuff, then select this one. You should set a password. If you double click here, you can set a password, whatever. But remember your password, because if you forget it, you are going to have a hard time to configure this CPU. You don't need a password, but you probably should have a password so people can get onto your CPU without you knowing it. And don't get onto your CPU at all. Well, what we're going to do now is to insert some modules, a digital input and just a digital input and an analog input module. Digital input module, they are reading binary information from your process. True false stuff, analog input, or reading analog values, let's say a temperature or something like that. So if you want to insert modules here, we can open the hardware catalog, and this is what I can select. You can see there's quite a bit I can do. So what I'm going to do is I want to digital input, just a basic type. What turn blue rectangles here is where I can insert them. That was one digital input. And then I said I want an analog input. Let's say what we want. We can take this one. It's okay. You see, they have properties or configuration possibilities like the CPU itself. Here is the option for the CPU. This is the option for digital input. This is a basic card, so probably doesn't have much options here. Not much. You can. But what you have to do is input output addresses. They start with address 0. There were 32 digital inputs, and they're grouped in bytes, and a byte is 8-bit, so it would require 4 bytes. 0, 1, 2, 3, 4 bytes. And you can see those up here too. And here too, the analog input has also addresses, and these addresses, that's where the CPU uses this address to say, okay, I want to get the values out of this module into the CPU and work on it. So if I want to look at this one, I could double click on it too, but it would go to the addresses. There are more than one way into it. But go back now, it was the analog one. Here we can do a little more configuration. First, there is what we call a channel template. Here we have got some diagnostic information that I could enable. No supply voltage. These modules, they have a supply voltage connected externally, and that one disappear. You can get a message into your program and say, okay, so no supply voltage, the module is not working. Overflow and underflow, the value is too high or too low, and so on. And also the type. This template is used by the channels, or can be used by the channels. So now it gets the setup from the template, this one, but I could say that channel 0, I want to do all by myself. So here I could say, okay, for this channel, if I could select them, it's a little slow. I want overflow and underflow in addition. I just select some. And here are the type of equipment you can interface. So if I got something called a 4-wire transducer or current 2-wire transducer, 40-20 milliamp, it's a lot frequently used, or use 40-20 milliamps as an analog input often. Then this has to match the actual device that they have in the field, what's measuring the signals, has to deliver 40-20 milliamps. Okay, and then there were the addresses. So now what we are going to do is that this information, the CPU automatically, we can do it in various ways, and you can configure a little of it here too. In this, we're not going to look into this, but they have to be transferred to the CPU, and the CPU uses tags for this. So here is, I already had, I have my digital input module started at 0, so I have 3 tags here. That percentage I 0.0, that's the first channel on the input module that I had. I switch to it here. 0.0, byte 0, byte 0, no, bit 0, the first channel. The last channel would be 3.7. So those were the binary inputs, and the program uses this name here, X1, to get hold of this one. It's stored in something called an input image here. So that was already configured, at least the 3 first channels, and then I have quite a few spares here. Now we're going to look at the analog input module, and here I'm just going to give it a generic name, AI, analog input, channel 1. And that's 16 bits, 2 bytes. So here I give it and they are always integer values, numbers, from plus and minus numbers. And okay, it says it was read, yes, because an input, an analog card uses words, input word. I think it was 4, wasn't it? That it was the first address. Let's see, there was this one. And now we have to look at addresses down here. You can see it over here too. It's the first address here. So that was correct. Now my program will use this name to access that channel, which I set to 4020 milliamps, some current transducers they have out in the field. So that is when you do your configuration, and what you do when you insert modules in here. At least you have to give addresses to the modules. That was what I was planning to do here. Just a quick one. You have digital outputs here. They are binary signals go out into the from the PLC to the process. I have got combi modules, combined modules. Say if I can. Here we have 16 inputs and 16 outputs, and so on. And I have also got analog input outputs, and I've got combined here too, some analog inputs and analog outputs. So analog outputs, they are just values. I write a value and then I get, for instance, a 4020 milliamp signal out of my CPU, out of my PLC to the field equipment to control it. Yes, and there's quite a bit more down there. Communication modules. If you want to communicate with other equipment or devices in your process, using serial communication, for instance, you can select modules here to do it. Okay, so this is the hardware catalog, what I can put into my rack. Okay, so this was a quick introduction to device configuration. So what we looked at is what you have to do is to at least know the network addresses, because if you don't know those, you're going to have a hard time to connect to the CPU and set it. Also, this address the CPU has a front panel that looked at, sort of was a small display there where you can enter this network address, and your program or your setup in your device configuration must match these addresses here. And then what we did was we inserted a digital input card. It didn't have it had properties, but not much you could do. But what's important is the input addresses, because they have to be put into a table so your program can access this information. The program you're making in your CPU can access this information. And then we also put into the project an analog input module with more possibilities. This one could, for instance, measure current signal, voltage signal, temperature signals, or whatever. We selected, just looked at one channel and selected the current signal, 4020 milliamp for that first channel. And then there was a template for the setup, so you could use the same setup for all channels, but I could override the template and set one manual. That's what I did. So again, this was a quick introduction to device configuration. There's quite a bit you can do, and you can just play around with it. You just make a project and look at what you can do.